Hi everyone, I'm Dhanasekaran, Assistant Professor, Department of ECE, KS Rangasamy College of Technology. Today we're going to see about 3 and 5 stage pipelining process in the course name of Embedded System. Before we going to see 3 stage and 5 stage pipelining process, we should know about what is pipelining. So pipelining comes under the advanced risk machine, that is risk is reduced instruction set computer. Here our aim is going to speed up the process. So how we going to speed up the process? We're going to fetch, decode and execute the process simultaneously. So by doing this simultaneously, we can improve the speed, so that the pipelining process used in the ARM, so which allows the memory system and the processor to work continuously. And the pipelining design for each ARM family is different. So this is the 3-stage pipelining architecture of advanced risk machine. So here we have address register, that is 32-bit, and with the incrementer and register bank, we are going to access the registers in the memory. And we have ALU bus, A bus and B bus, and multiplier, barrel shifter, and arithmetic logic unit, and instruction decode and control. Here when instruction comes to the ARM, and it will decode the instruction, that is first. Before that, the instruction going to be fetched in the address register, then it will decode and then it will execute. So in the register bank, you can select whichever the register you want, and you can access through the register bank. And barrel shifter, it will select the only one operand from the all among the all bits. That is given to the arithmetic and logic unit. In the arithmetic logic unit, all arithmetic logic operation going to be done. And after that, the data out register and the data in register is going to be the whatever the control going to make, whatever the task which is instruction decoding, that is going to be completed in this. And next, the 3-stage pipelining process, we saw that register bank and ALU and barrel shifter address all this in the black diagram. The very important of 3-stage pipelining process, one is fetch and decode and execute. So first, the instruction fetched from the memory and stored in the instruction register. Second, the decode process is going to be done. That in the decode process, the instruction is moved to the decoder, which decodes the instruction, and it's going to be activate appropriate control signals and the task the necessary steps for the next execution stage. That is the control signal which is generated from the decode signal, and it takes necessary steps for the next execution. In the execute stage, the instruction is executed. After executing that, the control signal, whatever that is data transfer or logical or arithmetic, whatever, all take place during the stage. So these are the 3-stage pipelining process. So this is the process, and which is going to be done as per this. You can see this add, subtract, compare. So first it will fetch the instruction. Again, it's going to be a decode and executed. First instruction, if you take add as the first instruction, and second instruction is subtract, and third instruction is compare. First instructions add, that's going to be fetched. Second, the second instruction going to be fetched, and the first instruction is decoded in the simultaneously. So third step in the third cycle, first instruction of going to be executed, second instruction going to be decoded, and third instruction going to be fetched. So these are the 3 cycles. So fetching, decode, execute, everything done simultaneously, so that we can improve the speed of the process. So these are the characteristics, advantage and disadvantage of three-stage pipelining process. Throughput, one instruction completed every 3 cycle, and focus on the achieve basic functionality and instruction processing. And advantages are simpler design and low power consumption, and disadvantages lower throughput. And next we going to see the 5 stage pipelining process. So this is little difference from the 3 stage pipelining process. Extra we have a buffer, data and write back. So already we have a fetch, decode and execute. Here we extra having a buffer, data and write back. So buffer is going to the memory access if required. Otherwise ALU results simply buffered for 1 cycle, and the write back is nothing but the results going to be stored back to the register. So this is the 5 stage pipelining block diagram, and we have a catchy here, and almost we have a 3 stage pipelining process things, but we have extra eye catchy, decode. So everything going to be the buffer data, and so write back to register. That is write back and buffer data things going to be happen in this. So coming to the processes here, the pipeline is that while one instruction is in the write back stage, other can be processing throughout the earlier stage simultaneously. So this overlapping significantly improves performance. So overlapping of process going to be done simultaneously. However, there can dependency between the instruction, where one instruction relies on the results of previous one. So in such cases, the pipelining may stall to ensure correct execution in order. So the characteristics and advantage of pipelining, 5 stage pipelining process. The characteristics is throughput and focus, and the potentially one instruction completed per 1 cycle, whereas a 3 cycle in the 3 stage pipelining process, and maximize the instruction processing efficiency through concurrent execution. So that is the characteristics and advantage of pipelining, 5 stage pipelining process: enhanced performance, instruction overlap, increased clock speed, and compacted design. Thank you so much.